Hi, welcome to another video. So Xiaomi just did something that almost nobody saw coming. At their Xring chip event on August 24th, they pulled out a small metal cube and casually announced that it can run 120 billion parameter models locally, right on your desk. No NVIDIA, no AMD, no Apple Silicon. This thing runs entirely on 3 of Xiaomi's own custom chips. It's called the AI Cube, and it might be the first serious challenger to NVIDIA's DGX Spark. And it's coming from a company that most people still think of as a phone and vacuum cleaner brand. So in this video, let's talk about what this thing actually is, how the 3 chips inside it work together, how it stacks up against the DGX Spark, the Mac Studio, and AMD's Strix Halo machines, and whether this actually matters for people like us who want to run local models without paying a monthly subscription to some AI company. So let's get right into it. First, what is the AI Cube? It's a mini PC, roughly in the same category as NVIDIA's DGX Spark or the Asus Ascent GX10. It's an aerospace-grade aluminum unibody, and Xiaomi being Xiaomi, they made sure to mention that the casing has exactly 33,874 CNC precision-cut perforations for cooling. I mean, only Xiaomi would count the holes. The whole thing sustains up to 150 watts of continuous power, and that matters for inference because these small boxes usually throttle hard when you push them for long. But the real story here is not the box. It's what's inside. There are 3 custom chips in this thing, all designed in-house by Xiaomi's Xring division, and each one has a completely different job. The first chip is the Xring O3. This is Xiaomi's new flagship mobile processor, and it's honestly a monster on its own. It's built on TSMC's 3nm N3P process with 24 billion transistors. It has a 10-core CPU with an all-big core design, meaning there are literally no efficiency cores. You get 2 ultra cores at 4.35 GHz, 4 premium cores, and 4 pro cores. On top of that, there's a 16-core G2 Ultra NX GPU that Xiaomi designed themselves and an NPU that does 200 TOPS. It's also the first mobile chip in the world to support LPDDR6 memory. For context, this chip scored over 5.2 million on Antutu, which is the first time any mobile chip has crossed 5 million. So, in the Cube, this chip is basically the brain that handles the system and the smaller on-device models. The second chip is the Xring O100, and this is where things get really interesting. This is a dedicated AI accelerator built on a 6nm process with 3D wafer-level stacked packaging. That means the memory is stacked directly on top of the compute, connected through 28,652 data lines. And because of that, it delivers up to 1.22 terabytes per second of near memory bandwidth. Now, if you've watched my videos on local LLMs before, you know that memory bandwidth is the bottleneck for inference, not TOPS, not core counts, bandwidth. And 1.22 terabytes per second is a genuinely absurd number for a box this size. We'll come back to this in the comparison. The third chip is the Xring D100. This is technically Xiaomi's new smart driving chip for their EVs, built on 3nm, with a 20-core CPU and a 16-core NPU. But inside the Cube, it's doing the heavy lifting for the big models because it supports up to 160 gigabytes of unified memory and can handle models with up to 200 billion parameters. So, the way the whole thing works is pretty clever. In the demo, Xiaomi showed the Cube running a 120 billion parameter model and a small 3 billion parameter model at the same time, with a fast and slow switching system. The small model handles the quick, simple stuff instantly, and the big model kicks in when you actually need deep reasoning. It's basically a router setup like what the big labs do in the cloud, except this is all happening locally in a box on your desk, which is just amazing. Now, let's talk about the market, because this is where it gets spicy. The obvious comparison is NVIDIA's DGX Spark. That's the golden box. Everyone bought for local AI, and it costs around $4,000. It gives you 128 gigabytes of unified memory, which sounds great until you look at the bandwidth, which is only 273 gigabytes per second. And if you've seen the reviews, that bandwidth is exactly why the Spark disappoints people. It can load huge models, but it generates tokens slowly because the memory just can't feed the GPU fast enough. Now, compare that to the AI Cube. 160 gigabytes of unified memory versus 128, and 1.22 terabytes per second of near memory bandwidth versus 273 gigabytes per second. That's roughly 4.5 times the bandwidth of the Spark. On paper, this thing should absolutely demolish the Spark at token generation. What about AMD, the Strix Halo machines, like the Ryzen AI Max 395 boxes, give you 128 gigabytes at around 256 gigabytes per second, and they cost around $2,000. Great value, same bandwidth problem. And Apple? The Mac Studio with the M3 Ultra gets you around 819 gigabytes per second and up to 512 gigabytes of memory, but a decently spec'd one costs as much as a used car. So, if Xiaomi's numbers are real, the Cube sits in a very sweet spot. More bandwidth than everything except the highest-end Apple and NVIDIA workstation gear, more memory than the Spark, all in a 150-watt cube. And there's a bigger story here too. Xiaomi has committed around $7 billion to chip development over 10 years, and this event was them showing off the results. The same company now designs the chip in your phone, the chip in their electric cars, and the chip in this AI box. That's the kind of vertical integration that only Apple really has today. And with all the export restrictions on NVIDIA hardware in China, there's a massive domestic market that desperately wants exactly this kind of homegrown local AI machine. So strategically, this makes a lot of sense. But, and this is a big but, let's pump the brakes a little. First, the AI Cube is an engineering prototype. There's no price, no release date, and Xiaomi says the O100 and D100 chips are only going into commercial products in 2027, so this is not something you can buy this year. Second, there are zero public benchmarks. We have no tokens per second numbers, no prefill speeds, nothing independent, and that 1.22 terabytes per second figure is near memory computing bandwidth, which is not necessarily the same thing as the full system bandwidth you'd get when running a real model across 3 different chips. Splitting inference across a phone chip, an accelerator, and a car chip sounds cool, but the software stack, to make that seamless, is really hard to build. NVIDIA's biggest moat was never the hardware, it's CUDA and the whole ecosystem on top of it. So take all these numbers with a grain of salt until real reviews exist. And third, we don't know what the software support looks like at all. Will it run llama.cpp? Will there be day one support for open models like Qwen, DeepSeek, and GLM? For Chinese open source models, almost certainly. For everything else, we'll have to see. So here's my take. Even as a prototype, this matters. For the last year, local AI hardware has basically been a three-way race between NVIDIA, Apple, and AMD, and all of them make you choose between memory capacity, bandwidth, and price. If Xiaomi ships this thing anywhere near its claimed specs, at a typical Xiaomi price, the DGX Spark instantly looks like a bad deal. And even if the Cube itself never ships, the pressure alone is good for us because competition is the only thing that ever makes this hardware cheaper. Combine that with Chinese open source models already being the best value models around, and you can see where this is going. A fully local, fully subscription-free AI stack that doesn't involve NVIDIA at any step. That's a big deal. A phone company just walked into NVIDIA's territory with 3 chips it designed itself, and the specs, at least on paper, are legitimately competitive. Now they just have to actually ship it. Please share your thoughts below and subscribe to the channel. I'll see you in the next video. Until then, bye.